In this video, we're going to have a look at calculating the probability of two independent events occurring. So to calculate the probability of an independent event, so for example, probability of event A and B, we want to multiply the probability of event A by the probability of event B. So let's have a look at the steps that would be required. The first step is to calculate the probability of event A from happening. Second step is to calculate the probability of event B happening. And then the third step, once we've got those two separate probabilities, is to calculate the event of A and B occurring by multiplying the two probabilities together. So let's have a look at an example of how to calculate the probability of independent events. So let's have a look at the example. Josh and Temi are competing in different sections of a chess tournament. Josh estimates that his chance of winning against his opponent is 3 in 5, whereas Temi estimates that her chance of winning against her opponent is 5 in 7. We want to find the probability that both Josh and Temi win their chess game, that both Josh and Temi lose their chess game, and the probability that Josh loses his game but Temi wins her game. So let's have a look at how do we do these calculations. So the first one we're looking at is the probability that both Josh and Temi win their chess game. And to do that, we need to find the probability of Josh winning and the probability of Temi winning. So starting off with Josh. So the probability of Josh winning, as per the question, is 3 out of 5. And the probability of Temi wins, as per the question, is 5 out of 7. So now that we have the probability of Josh winning and the probability of Temi winning, we can find the probability of both Josh and Temi winning at the same time. And to do this, we multiply the probability of Josh winning and the probability of Temi winning. So the probability of Josh winning is 3 out of 5. And we multiply that by the probability of Temi winning, which is 5 over 7. When we multiply fractions, we multiply the numerators and then multiply the denominators. So 3 times 5 is 15, 5 times 7 is 35, and we can simplify that to 3 over 7. So the probability that both Josh and Temi win their game is equal to 3 over 7. In the next part of the example, we want to calculate the probability of both Josh and Temi losing their chess games. So the probability of Josh losing is going to be equal to 2 out of 5, assuming that there's no draws. And that was calculated by assuming that if he wins 3 out of 5, then he's going to lose 2 out of 5. Next, we need to calculate the probability that Temi loses, and that is going to be 2 out of 7. Again, if she wins 5 out of 7, then we are going to calculate the probability of her losing is 2 out of 7. So now that we've done our individual calculations, we can calculate the probability of both Josh and Temi losing, and we're going to do that by multiplying the probability that Josh will lose times the probability that Temi will lose. So that is going to equal the probability of Josh losing, which is 2 out of 5, times the probability of Temi losing, which is 2 out of 7. So multiplying my fractions together, the probability is going to be 4 out of 35. So the probability that both Josh and Temi lose is 4 out of 35. So finally, we're going to calculate the probability that Josh loses his game, but Temi wins her game. So first we need to calculate the probability of those two events happening. So the probability that Josh loses his game is 2 out of 5. And the probability that Temi wins her game is 5 out of 7. Now that we've got our two individual components, we can calculate the probability of Josh losing his game and Temi winning her game. And we do that by multiplying the probability that Josh loses by the probability that Temi wins. So that's going to equal Josh's probability of 2 over 5 times Tammy's win probability of 5 over 7, and that is going to equal 10 over 35, which equals 2 over 7. So the probability that Josh wins and Tammy loses is equal to 2 over 7. So that's examples of how do we calculate the probability of independent events.